This is lesson 7-2, definite integrals. So let's start off with a particular function, f of x is equal to x. And as you can see on the graph here, I have graphed that function. So let's say that I want to find the area under f of x between x equals 2 and x equals 5. So basically, I'm looking at this area here, okay? I'm trying to determine what that area is. Well, if you look at that area, it's simply a trapezoid. And we know the area of a trapezoid is equal to 1/2 the sum of the bases times the height. Now, the only difference is here, you got to remember that the bases are the parallel sides. And the parallel sides here are actually vertical, okay? So this right here is B1, and this right here is B2. And what we normally refer to as the height is this horizontal dimension between 2 and 5. So if we plug in the values for B1, B2, and H, we come out with the area is simply equal to 10.5. So instead, let's say we wanted to calculate the area using an integral, okay? So we would say that the area is equal to the integral of x dx from 2 to 5. So the integral of x is simply x squared over 2. Remember, we add 1 to the exponent and we divide by that new exponent, all right? So we plug in 5 for x, and it becomes 25 over 2. We plug in 2 for x, and it becomes 4 over 2. We subtract those two numbers, and what do we get? The same as we got before, 10.5. Well, suppose instead of a straight line, we had a parabola. In this case, we have f of x is equal to x squared plus 1. And we wanted to find the area under this curve from x equals 2 to x equals 5. Again, we're talking about this area in here that we want to find. Now, we don't have a straight line. Remember, we got a parabola. So therefore, it's going to be not as straightforward a geometric problem as it was before. But let's see how we can do this. So we're going to use an integral again. We're going to say the integral of x squared plus 1. Remember, x squared plus 1, that's simply the function, okay? The integral of x squared plus 1 from x equals 2 to x equals 5. Well, first of all, the integral of x squared plus 1 is going to be x cubed over 3 plus x, okay? Remember, we add 1 to the exponent and divide by the new exponent. So x to the third over 3 plus x. Now, I'm going to plug in 5 for x, and I get 5 cubed over 3 plus 5. Then I plug in 2 for x, and I get 2 cubed over 3 plus 2. If I subtract those two numbers, I come out with the area between 2 and 5. Remember, we're talking this area in here. We come out with that area is equal to 42. All right, so now let's look at another straight line, but let's say that we've got this straight line here of x over 3 minus 1, all right? And we're looking to find the area under f of x from x equals minus 2 to x equals 4. Now, the term under isn't actually that specific. The implication is it means that it's below, all right? But it really isn't that in all cases. For example, in this case, under the function means the area between the function and the x-axis. So we have this portion here, which is actually negative, and then we have this small portion up here, which is actually positive. So when it says under, it basically is, it's actually saying that the area between the function, the line of the function, and the x-axis. It can be below the x-axis or above the x-axis or a combination of the two. So again, if I take the integral from -2 to 4 of this function, which is x over 3 minus 1 dx, okay, the first part is going to be, the integral of this is going to be x squared over 6 minus x, okay? So first I'm going to plug in 4 for x, and then I'm going to plug in minus 2 for x, and subtract them, and I come out with an area. Notice it is -4. And if you think about it, this portion between the x-axis and the function is a lot bigger than this portion over here to the right that's above the x-axis. So it makes sense that the total area here is going to come out negative. All right, so now let's look at some properties of definite integrals, all right? And most of these are going to be pretty obvious, but I think that it's worthwhile still to have them, to state them. The first of these is called the zero integral, and that is the integral of f of x dx from a to a, all right? When the two limits are the same, the answer comes out 0. Pretty obvious. So now let's look at multiplying by a constant k. So if we've got the integral from a to b of k f of x dx, we can take the k outside the integral and simply say that's equal to k times the integral from a to b of f of x dx. Now let's look at negation, all right? So if we got the integral from b to a of f of x dx, well, that is equal to minus the integral from a to b of f of x dx. So notice when we change the limits, the order of the limits, it becomes the negative, all right? Now let's look at what is referred to as decomposition, all right? Let's say that we've got a is less than c is less than b. In other words, c is between a and b. So if we've got the integral from a to b of f of x dx, that's equal to the integral from a to c of f of x dx plus the integral from c to b of f of x dx. Now, let's look at addition. Let's say we've got the integral from a to b of f of x plus dx, f of x plus gx dx. So we're asking for the integral of a sum. Well, that is simply equal to the sum of the integrals. So the integral from a to b of f of x plus gx dx is equal to the integral from a to b of f of x dx plus the integral from a to b of g of x dx. And now the last of these is subtraction. Again, if we have the integral of a difference, it's equal to the difference of the integrals. Or the integral from a to b of f of x minus gx dx is equal to the integral from a to b of f of x dx minus the integral from a to b of g of x dx.